Onions are one of the oldest cultivated foods on Earth, grown and consumed by humans for more than 5,000 years. Yet the way onions reach modern supermarkets bears little resemblance to how they were once pulled from the ground by hand. What seems like a simple vegetable stacked in bins is actually the result of a massive agricultural and industrial operation designed to harvest, dry, store, and ship millions of onions with minimal waste, maximum shelf life, and consistent quality. Behind every dry onion lies a carefully timed process involving mechanized harvesting, controlled curing, airflow engineering, optical sorting, and automated packing systems operating at incredible scale. And today on the How Factory, we're going deep into onion farms and processing facilities to see exactly how onions are harvested, dried, and packed by the millions for global markets. Onions have played an important role throughout human history. Ancient Egyptians revered onions for their layered structure, believing they symbolized eternity. Roman soldiers consumed onions for strength, and medieval farmers relied on them as a staple crop because of their ability to store for long periods without refrigeration. That natural shelf stability made onions one of the earliest foods traded across long distances, and it's precisely that trait modern agriculture has perfected through technology. The process begins months before harvest in vast onion fields. Onions are planted either by seed or by sets depending on the variety and climate. Modern farms use precision planters that place seeds at exact depths and spacing, ensuring uniform bulb size at maturity. Throughout the growing season, irrigation systems deliver carefully measured water, and soil nutrients are monitored constantly. Onions grow underground, storing energy in their bulbs while green tops above ground photosynthesize. As harvest approaches, farmers reduce irrigation, signaling the onion to stop growing and begin preparing for dormancy. Harvest timing is critical. Onions must be harvested when their tops naturally fall over and begin to dry. This top-down stage indicates the bulb has matured and its outer layers are ready to protect it during storage. Harvesting too early reduces shelf life. Too late increases the risk of disease or splitting. When conditions are right, mechanized harvest begins. Modern onion harvesting is almost entirely mechanical. Large harvesting machines move slowly across the field, lifting onions from the soil using undercutting blades. These blades loosen the earth beneath the bulbs, allowing them to be pulled upward gently. Conveyor systems lift the onions, shake off excess soil, and lay them back onto the field in neat rows. At this stage, onions are not ready for storage. They still contain moisture and must be dried. Field drying, also called curing, begins immediately. Onions are left in rows on the soil for several days, allowing sun and airflow to dry the outer skins and necks. This step seals the bulb, preventing moisture loss and bacterial entry during storage. Weather conditions are closely monitored. Rain can ruin curing onions, so timing and forecasting are essential. In regions with unpredictable weather, onions may be moved quickly into covered curing facilities instead. Once field curing reaches the desired level, onions are collected using pickup machines. These machines lift the onions again and feed them into trucks or trailers for transport to processing facilities. From this point on, the process becomes increasingly controlled and industrial. At the processing facility, onions are unloaded and immediately inspected. Dirt, stones, and plant debris are removed using vibrating screens and airflow separators. Onions pass through washing or dry cleaning systems depending on market requirements. Unlike fresh produce meant for immediate sale, storage onions are typically cleaned without water to avoid introducing moisture. Drying now becomes the most critical stage. Even after field curing, onions must undergo controlled drying to achieve the moisture balance required for long-term storage. Facilities use large drying tunnels or warehouses equipped with powerful ventilation systems. Air temperature, humidity, and flow rate are carefully controlled. The goal is to dry the outer layers and neck completely without dehydrating the inner flesh. Too much moisture leads to rot. Too little causes shrinkage and weight loss. Onions may remain in curing facilities for days or weeks depending on variety and destination market. Sensors continuously monitor temperature and humidity throughout storage piles that can reach several meters high. Air is forced upward through perforated floors, ensuring even drying across thousands of tons of onions. This engineering allows onions to be stored safely for months. Once cured and stabilized, onions move to grading and sorting. Conveyor systems feed onions into optical sorting machines equipped with high-speed cameras and lasers. These systems analyze each onion for size, shape, color, and surface defects. Onions with soft spots, mold, cuts, or abnormal growth are automatically ejected using air jets. This step ensures only healthy bulbs move forward. Sizing is especially important. Different markets require different onion sizes, from small onions used in food service to large bulbs sold individually in grocery stores. Sorting machines use precise rollers or belts that separate onions by diameter. Each size category is routed to a different packing line. After sorting, onions undergo trimming. Mechanical cutters remove dried tops and roots to create a clean, uniform appearance. This step improves visual quality and reduces loose debris during packaging. Trimming systems are calibrated carefully to avoid cutting too deeply into the bulb, which would shorten shelf life. Quality control teams inspect samples throughout the process. Random onions are cut open to check internal quality, firmness, and moisture levels. Storage onions must remain dense and dry inside. Any batch showing signs of internal decay is isolated immediately. Now comes packaging, where speed and logistics dominate. Onions are packed in a variety of formats depending on destination. For retail markets, onions may be packed into mesh bags, paper sacks, or plastic-wrapped trays. For food service and export, they are often packed loose into large sacks or bins. Automated bagging machines weigh precise quantities and seal packaging at high speed. Mesh packaging is especially common because it allows airflow, reducing condensation during transport. Bagging machines form mesh sleeves, drop onions inside, insert labels, and stitch or clip the bags shut in seconds. At full capacity, a single line can pack tens of thousands of onions per hour. Packed onions move to palletizing systems, where robotic arms stack bags in optimized patterns to prevent crushing and maximize shipping efficiency. Pallets are wrapped and labeled with batch codes, origin information, and destination details. Traceability is critical, allowing onions to be tracked from field to store. Cold storage may be used depending on market demand. While onions are shelf-stable, controlled low temperatures extend storage life further. Temperature-controlled warehouses maintain onions at precise conditions, slowing respiration and preventing sprouting. Some onions may remain in storage for months before shipment, allowing year-round supply. Distribution is a global operation. Onions are shipped by truck, rail, and shipped to domestic and international markets. Logistics systems track inventory rotation to ensure older onions are shipped first. Export onions may undergo additional inspections to meet import regulations, including phytosanitary certification. Behind the scenes, sustainability plays a growing role in onion production. Onion skins, tops, and rejected bulbs are not wasted. They are used for animal feed, compost, or processed into extracts for food and pharmaceutical applications. Water use in processing facilities is minimized, and airflow systems are designed for energy efficiency. What makes onion processing remarkable is how a simple crop is managed at massive scale while preserving natural shelf life. Onions are living organisms even after harvest, constantly respiring and changing. Managing that biology through airflow, temperature, and handling precision is what allows millions of onions to remain usable long after leaving the field. From centuries ago, when onions were pulled by hand and dried in small bundles, to today's mechanized harvesters and climate-controlled warehouses, onion production reflects the evolution of agriculture itself. The goal remains the same: preserve a valuable food. But the tools have become industrial, precise, and global. From sprawling fields and rumbling harvest machines to drying tunnels, optical sorters, and high-speed packing lines, the journey of an onion is a carefully coordinated process few consumers ever see. Every layer of skin protects months of planning, engineering, and labor. And that is exactly how onions are harvested, cured, dried, sorted, packed, stored, and shipped, transforming humble bulbs into one of the world's most reliable and widely distributed food crops. Thanks for watching The How Factory, where we reveal how the world really works. Don't forget to like, subscribe, and join us again for more deep dives into the farms, factories, and systems that feed the planet.